Hello! Welcome to another video from DFS on Technology. In this video, I'm going to go into the remind algorithm in depth. Now, if you haven't seen the first remind video, I recommend that you take a quick look. If you have seen it, you may remember the remind algorithm being described as follows. Starting from today, remind checks to see if the date specification is satisfied. If not, it goes forward by a day and checks again, and it keeps doing this until it finds a date that satisfies the date specification or proves that no such date exists. You may also remember that in the video I said remind doesn't actually work that way because it would be too slow, but it behaves as if it works that way. So in this video, we're going to look at the C code that actually implements the algorithm to see exactly how it works. So first, a bit of a warning. We're going to be looking at C code, so it helps if you've had some programming experience. You don't need much C experience, although that will help, but you do need to at least have programmed in one or two other languages. So with that out of the way, let's go and take a deep dive into the remind algorithm. Our first step on the way to learning the remind algorithm is to look at how remind represents dates internally. A date in remind is represented as the number of days since the beginning of time, stored in an int variable. Remind considers the beginning of time to be Monday, January 1st, 1990. A 32-bit signed integer lets us represent dates up until the year 5,881,479 approximately. Now remind clearly won't work properly for the next 6 million or so years because the Earth's rotation is changing and the calendar is going to drift. One last bit of business before we can get into the workings of the remind algorithm has to do with parsing. When you create a reminder file, you might create something like rem February 24th message meeting, which is a convenient representation for human beings, but not so convenient for computers. So what remind does is it parses the input with a special module called the parser, and it converts it into an internal representation that is more convenient for a computer to deal with. What we see here is remind's internal representation of the rem command line. It is a C structure. In the C language, when you have a whole bunch of different variables that are all sort of related to the same thing, you package them up in a structure. It's kind of like putting all of your toys in a box and wrapping up the box, and now that's your toy box, which you can treat as a unit. Now this structure is, to put it mildly, rather full-featured, but feel free to uncurl from the fetal position, because for the purpose of this video, we're only going to care about 4 of the members of the structure, which are the ones highlighted in this picture. They are WD, which is a list of the weekdays, if any, found in the rem command, so that would be Monday, Tuesday, Wednesday, so on. There's D, which is the day of the month, if a day of the month was supplied. M, which is the month, if the month was supplied. And Y is the year, if the year was supplied. So with that information under our belt, we can go ahead and classify all the different types of simple reminders that you can have. The first step in classifying the simple triggers is to figure out the different types of triggers that you can have. There are 4 possible components of a trigger. The first component is a weekday, such as Monday or Tuesday. That can either be present or absent. Now it so happens you can have more than one weekday in a date specification, like you could have Monday, Tuesday, Wednesday, Thursday, Friday, meaning any working day. But for the purpose of classification, we only distinguish between not having a weekday and having at least one weekday. The next component that we can have is a day of the month, a number from 1 to 31. We can only have one of those if we have one, so there are either 0 or 1 of those. Same with the month, we either have a month or we don't. And same with the year, we either have a year or we don't. So given these 4 different categories, each of which can either be present or not, we end up with 16 different types of simple triggers. And all of the possibilities are listed in this table. So for example, if you have nothing at all, no weekday, day, month, or year, if you just have rem message, well, that gets triggered every day. Any date will satisfy that specification. That's on the first line. If you have a day, a month, and a year, then the reminder is triggered only on that specific date. If you have a weekday, a day, and a month, then it is triggered on the first weekday on or after that day of the given month in every year, and so on. So we're going to go through the code and look at some of these 16 cases to see how the remind algorithm handles them. Here I am in a checked out copy of the remind git repo. If you're going to follow along, I'd recommend following from git master. And if we look in that directory, we'll see a bunch of files and subdirectories. The one we're interested in is source. And if we look at the C files in that directory, there are a bunch of them. But for the purpose of this video, the one we're interested in is trigger.c. So I'll go ahead and I will open trigger.c in everybody's favorite editor. And the function that we're interested in for this video is called next simple trig right here. And what this does is it computes a simple trigger date. And by simple, we mean you have 0 or more weekday components, 0 or 1 day of the month components, 0 or 1 month components, and 0 or 1 year components. So it only deals with that. It doesn't deal with skips and omits and befores and afters and satisfies and repeats and all the advanced reminder stuff. Just the simple stuff. This routine is used as a subroutine by more complicated routines that do the full-featured reminders. So let's take a look at this function. It returns an int, and the int that it happens to return is a date. That's the number of days since the beginning of time, since January 1st, 1990. It takes 3 arguments, a start date, which again is expressed in the number of days since 1990. Typically that would be today, but doesn't have to be. It's given a trigger structure, which has been very carefully and methodically filled out by the parser as it reads the reminder file. And this final function is a return variable. It's a pointer to an integer, and if something goes wrong, next simple trig can put an error code into that variable so the caller knows exactly what went wrong. So I'm only going to show a few of the cases because otherwise this video would be much too long, but let's get into it. So the first thing we do is we set the error return code to 0, meaning no error. We assume it's going to work. Then we call this function from Julian, which takes a date, which is the number of days since January 1st, 1990, and converts it into a year, month, and day. Now, there's a little wrinkle here. The months are numbered 0 to 11 instead of 1 to 12. 0 is January. And the reason is that in a few places in Remind, we use the month number as an index into an array, and C likes to index arrays starting from 0. So that's just a little thing you have to keep in mind. Months are numbered from 0. The day of the month and the year are conventional. They're the same as what you'd normally write them. So anyway, we convert our start date into year, month, and day, and we make a copy of it because some of the cases use the copy. The next 4 lines, which is these 4, are basically sorting out which case we have. So you remember that table from a few minutes ago? We're trying to figure out which row in the table we're in. So if we have a day of the month in our trigger, so the parser fills in the day, the month, the year, and the weekday. If it doesn't find a day, it fills in a special value called no day in the trigger structure. No day is an illegal value, and if we go look at what it is defined as, no day is defined as -1. No month is defined as -1, and no year is defined as -1 because those are not valid values. No weekday, on the other hand, is defined as 0, and I'll explain why in just a minute. So let's go back to the code. So if we have a day, then we OR our type with got day. So let's go take a look at what the heck got day is. So got day, got month, got year, and got weekday, these are just bit masks. This is the bit 0, bit 1, bit 2, and bit 3. And so essentially what these 4 if statements do is, based on what we have in our reminder, we end up with a number from 0 to 15, where 0 means we got nothing. It's just like rem message whatever. And 15 means we got everything. So we sort out our cases. And then we have a switch statement, which is basically C's way of picking among a number of cases. So let's take a look at a few of those cases. I'm not going to look at them all. So case 0 means we have nothing. That's this row in the table here. So any day is a valid day. So the first day on or after the start date that satisfies the date spec is the start date. By definition, any day will do. So we just return where we're starting from. This next case, we have a weekday, like let's say, for example, Wednesday. That's this row in the table. So what we do is we advance to the next weekday that satisfies the criteria. So let me explain how weekdays are represented in the trigger structure. Inside remind, weekdays are numbered from 0 to 6. 0 is Monday. What, you say? Why is 0 Monday? Why isn't it Sunday? The reason is that the beginning of time, which we all know is January 1st, 1990, happens to be a Monday. So if you have a date, that's the number of days since that day. If you take the remainder upon dividing it by 7, it will give you the weekday. And if you number your weekdays starting from 0 being Monday, then you get the proper weekday. It's just for convenience. That's the only reason Monday is defined as 0. The parser, when it parses out the weekday components of the rem statement, it sets the bits corresponding to the weekdays that it finds. So for example, if in your reminder file you have rem Monday, Tuesday, Wednesday, it will set bits 0, 1, and 2 in this WD value. So now with that knowledge under our belts, we can go look at the advance to weekday macro. It is a macro. And it looks like this. So we're given a date and a bit mask of weekdays. Now, one subtle thing to realize is that we're guaranteed that at least one of bits 0 to 6 in this value is set. The calling code ensures that, because if we pass in a 0 here, we'd have an infinite loop, and that's considered undesirable in computing, and it would make this video quite long. Anyway, how does the macro work? We take the date that we're given, that's x. We take the remainder upon dividing that by 7. So the number of days since the beginning of time, we divide it by 7 and take the remainder. We then take the value 1 and we shift it left by that much. So it's going to be 1 shifted left 0 for Monday, which is 1, all the way up to 1 shifted left by 6 for Sunday, which would be 128. And then we check, is the bit corresponding to that shift set? And if it's not the case, in other words, for as long as the weekday constraints are not satisfied, check the next date. So this increments to the next day. So it kind of searches forward until it finds a weekday that works. It'll at most go 6 times because one of the bits is guaranteed to be set. Okie doke. So that's this case where we only have a weekday. I'll show you 2 more cases. The one where we have, let's say, a day and a weekday. So this could be, for example, here we go. This could be, for example, like the third Monday in a month would be Mon 22. So the first Monday on or after the 22nd of the month is the third Monday of the month. This is quite a complicated case. So what this if statement does is it says if we're not at January 1990, in other words, if we're not at the month that's at the beginning of time, check the previous month. So we go back a month. If we went back from January to December, then we decrement the year and we set the month to December. That's what this if statement does. If that month has enough days for our day constraint, in other words, if I asked for the first Monday on or after the 31st of a month, then only months with 31 days in them would be considered. So that's what this if statement guards against. It guards against a month that has too few days. We convert last month, so that's Y2 and M2, that's the month that we moved backwards from. We convert last month and the day that we want into the number of days since the beginning of time. And then we advance forward to the first acceptable weekday. And if the result is greater than or equal to our starting position, we're good, return it. So let me give you a concrete demonstration. Here's a calendar of 2021. Let's say I asked for the first Tuesday on or after the 28th of a month. And let's say that today is February 1st. The trigger date is February 2nd. For Remind to figure that out, it has to move to the previous month, which is January, and then starting from January and the day we asked for, the 28th, then it bumps forward until it hits a Tuesday, which happens on February 2nd. Since that is greater than our starting point, we return February 2nd. However, if today is February 3rd, and we do that exact same calculation, we go back to the 28th of January and we bump forward to a Tuesday, that's the 2nd, it's not greater than our starting point, so we do not execute this return statement. Instead, we fall down to here. And in this case, we say if the day we're asking for is less than or equal to the number of days in this month, in other words, if this month has enough days for it to work, we convert this year and this month and then the day we're after into the number of days since the beginning of time. We advance to the first satisfactory weekday, and if the result is bigger than our starting date, we return it. So let me give you an example of how that might work. Let's say that today is February 17th, and we're asking for the first Thursday on or after the 12th of the month. So we start from this year, 2021, this month, February, and the day we're after, which is the 12th, and then we bump forward to the next Thursday, which goes bumping along here until the 18th. The 18th is greater than or equal to our starting point, so we return it. On the other hand, if today were the 25th, and we asked for the first Thursday on or after the 12th, we do that same calculation, start from here, bump to the 18th. It's not greater than or equal to our starting point, so we don't execute this statement, so we end up here. So the only thing to try is the next month. So we get next month, and again we check if this month is December, then we've gone to the next year. So we reset the month to January and increment the year. And then we keep going forward until the month that we're looking at has enough days in it, because you have to guard against trying to do this calculation on a month with insufficient days. Then we do the same thing. We look at the year, the month that we've moved to, and the day we're after. We advance to the first weekday that satisfies the date. And here we know that J is going to be greater than the start date because we're already in next month, so we return it. So let me illustrate how that case would work. Again, let's say that today is the 25th, and we asked for the first Thursday on or after the 12th, we'd first calculate it to be 14th of January in the first part. That's too early. We'd then calculate the 18th of February. That's too early. So then we'd go to March 12th and bump ahead to March 18th and return that. And that is definitely after February 25th. So that is the most complicated case that I'm going to show you. The ones where we have days of the month along with weekdays tend to be complicated. The last one I'm going to show you is the simple one where we have a year, a month, and a day right here. In this case, we've got all three components. That's this row in the table, and this one's dead simple. First of all, we check that the caller is not trying to do something silly like ask for February 30th. So if the day we're asking for is greater than the number of days in the month, then it's like, no. We set our error return to invalid date specification, and we return -1. Otherwise, we just take the year, the month, and the day that we're after, and we convert it into the number of days since January 1st, 1990, and return it. In this special case, we don't actually return -1 for an expired reminder. We return the date, because this is useful for callers in some cases. I also want to comment that Julian and from Julian are badly named. The number of days since January 1st, 1990 is certainly not the Julian date. It's a terrible name, but I didn't really know that when I started writing Remind. I thought a Julian date was just the number of days from any old starting point. But it turns out, no, that is not the case. Anyway, I'm not going to go through any more cases because I think this has given you a flavor. I would encourage you to download Remind and take a look at this function and satisfy yourself that it does actually work the way that I described the Remind algorithm as working, and also satisfy yourself that it's a lot faster than if you just implemented the algorithm the way I described it. Well, that's it for our introduction to the implementation of the Remind algorithm. I hope you enjoyed this video. If you did, please hit like, please subscribe, and I hope to make more of these videos in the near future, so I hope to see you again sometime soon. Thanks for watching.